Unless you're living in a cave for a couple of decades, you know that our planet commands us to reach net zero carbon by 2050.
You gotta be kidding me, bro!
What you maybe don't know yet is how much of a water industry topic that is. Why? Well, simply because our sector's direct emissions are significantly larger than aviation or all the cars on the road in the USA. So how can we collaborate across the water value chain to reduce our greenhouse gas emissions? What needs to change in our energy, waste and sustainability approaches? What are the tools and the shifts in leadership and management it involves?
I need answers.
Let's review. First things first, what is net zero? Well, it's pure mathematics. You take the greenhouse gas your activities produce and you subtract the one you remove from the atmosphere. If you reach equilibrium, you're at net zero. Above, you'll be in trouble, especially given the Paris agreements, and if the result is negative, you're a good pupil. Now, if you're just starting out with the carbon topic as I do, shame on me. There's one more thing to understand about net zero. It doesn't mean you're not emitting any carbon or greenhouse gas. It means that you offset at least as much as you emit. This is why we see different kinds of pledges between the net zero commitments and the zero emission ones. And of course, the logical order is to start with net zero to ultimately reach zero emissions.
Of course, it makes perfect sense now.
Okay, but what does it mean for the water industry? Well, water handling is an energy-intensive process, be it water supply, conveyance, treatment or distribution, wastewater collection, treatment or discharge. All of these process steps involve a degree of energy intensity. Altogether, the water sector is directly responsible for up to 10% of the world's carbon emissions.
How much?
That's about 5 times more than the aviation sector, and it could ironically worsen if we were to reach the UN SDG 6.
You think I'm kidding? It's not a joke.
Indeed, that would mean an additional 44% of treated wastewater, representing an additional energy burden. And additional process emissions, we'll come back to that. Yet, this 10% impact is still an average figure. Depending on the availability and quality of water, the carbon impact may differ. While good quality surface water comes carbon-free, desalination involves about 3 to 4 kilowatt-hour per cubic meter and the associated carbon impact, which hints to a double circle here. Carbon emissions cause global warming that increases water scarcity and pushes us to use alternative sources of water, which ultimately end up generating more carbon emissions.
That's a lot to take in.
You see, if the world is decarbonizing, it will rapidly end up pointing at the water industry and asking us to do the same. But wait, here's the catch. That's an opportunity. What is a good net zero? When discussing with Maria Maninaki, it rapidly became clear to me that we had 3 ways to solve the carbon riddle. Option 1, we consider ourselves green, evaluate how much carbon we emit, and just offset it. Now, at the scale of the water sector's emission today, that may represent unrealistic amounts of trees to plant and atmospheric carbon to capture.
I have another idea.
Option 2, we declare our emissions to be mostly energy related and hence wait for the energy sector to do its work and turn 100% carbon free to pat ourselves on the back and claim we are now the greenest industry there is. Problem, that's quite a passive take on the matter, and worse, it doesn't solve for our direct emissions, especially on the wastewater side of the equation. Hence, Maria introduces the concept of a good net zero.
When it comes to good net zero, is about following good science according to the Paris Agreement trajectories and say, what can I do to take some steps and reduce? You're essentially looking at reductions over 90% of your baseline by 2050 before you offset the remaining 10. Good and bad, it's always difficult to define, but the important message here is that it's not a simple equation, just carbon neutrality or net zero, so the net effect is zero, is more than that. And we have to do as much as possible to reduce and eliminate and avoid those emissions before we accept there will be a small amount of residual emissions to remove from the atmosphere.
That's why we may want to go for option 3. We have a unique opportunity today to invest in the right approaches. There are countless options to do so. We'll review some in a jiffy. And one simple truth, the investment will cost the same today as in a somewhat distant future. And if we move now, we can start reaping the benefits today.
Now it's time to play.
But let's agree on some definitions first. What is a carbon footprint? A company's carbon footprint is the total amount of greenhouse gases that are generated by its direct actions. For many industries, this is a very convenient and relevant measurement. But is it for the water industry?
Doubtful.
I'd say not across the supply chain. Let me give you an example. At GF Piping Systems, we strive to put together the most reliable way to convey water. Our carbon footprint is hence defined by all the carbon emitted while producing our pipes, fittings, actuators, or sensors. But what if we were supplying pipes with a stupidly high roughness? It may trigger much higher pumping needs, hence a whole lot of energy. Yet, that wouldn't impact our footprint. We don't supply the pumps, and we don't operate them, so the utilities footprint would be heavily degraded, while we would still be the good pupils. This is why, beyond carbon footprint, there's an additional measure that's more meaningful across the water value chain.
What is it exactly that you're trying to show me?
What is a carbon handprint? The carbon handprint is the greenhouse gas impact of a product when used by a customer. Said differently, the carbon handprint of a supplier is the way he impacts the carbon footprint of the other steps in the value chain. And in the stupid, of course, example I took before, our very rough pipes would have a terrible handprint. So that is probably the best metric to look for to assess the water industry's supply chain's impact on the race to net zero water. Now, if handprint is the best metric, why shall we still care about footprint? In fact, there's a psychological element to it. As the water industry's supply chain, we have to demonstrate some leadership and show the way.
This is the way.
As Lisa Marchuka shared during the conference, although we are not major water users, it is important to hold ourselves accountable. This is why, even if Lisa's customers use 65,000 times more water than Evoqua does,
That's a lot.
the company still sets some ambitious footprint targets. Same for the other companies of my panel, Xylem, Jacobs, Mott MacDonald, or GF Piping Systems. Did your water company also take footprint or handprint pledges? Come tell me in the comments. Now, if we decide to walk the talk, it means we'll have to step out of business as usual approaches and review our practices. The good news is, as Xylem showed, that there are plenty of low-hanging fruits in that endeavor. For instance, 50% of energy-related emissions from the wastewater side of our sector could be eliminated with existing technologies. And all of that 95% of the time at zero or negative cost. And as Austin Alexander recalls, it is our duty as a supply chain to support our customers in reaping those benefits for the planet and for themselves.
Hey, user of our equipment, there's not only these typical specification items that you need to be concerned about, quality and meeting your operational specs, but we really need to get better at communicating the sustainability impacts as well. This energy savings isn't just a cost savings, but it also has greenhouse gas impact. We're really starting to get better at that. We have room to grow.
Where shall we start? Well, here's a non-exhaustive list of the items we might want to collectively begin with.
Let's go, let's go, let's go. Let's get it.
Water savings. Often referred to as a low-hanging fruit, to the despair of my estimated colleague Olivier Narbet, reducing non-revenue water is the first stop on our path to net zero. Every drop of treated water that goes missing represents energy that has been spent for nothing, and hence a carbon impact. A fact Victoria Edwards visually reminded us.
There's no other industry in the world that would produce something and then lose 40% of it. Can you imagine BMW building a phenomenal factory, producing 100 supercars and then burning 40 on the forecourt?
Let me think about that for a minute.
Next up, energy savings. We're using plenty of energy in the various stages of water management. A good portion of it hides in network pumps, which can be optimized quite consequently. As David Lloyd Owen recalls in his Global Water Funding book, pumps account for 10% of the world's energy consumption, and Grundfos estimates that 90% of them are not optimized.
Oh, okay.
The next section of the water cycle where energy is misused is probably the aeration tanks in wastewater treatment plants. They account for 60% of a plant's energy use, and even though it is probably the best we can do today, the activated sludge process still has this drawback of using energy to destroy energy. Remember how wastewater is actually liquid energy? It's not about turning the sector on its head in a couple of months, but as Stéphane Bessadi recalled, we can invest today in the innovations that will help solve those challenges tomorrow.
We are really trying to have this strategic and long-term approach. So not only to consider project development and implementation, but really to consider what will be the future operation for the coming 10 or 15 years.
Oh, that's so smart.
It's not.
It is, Bob.
Let's move to process emissions. So far we discussed energy, which is a good thing to reduce, for sure. Now, if the full electrical grid was to become renewable, the water industry could still gobble gargantuan amounts of energy and be carbon neutral. Probably not sustainable, but carbon neutral. But along our treatment processes, and especially in wastewater treatment plants, we will keep emitting greenhouse gases. And as Maria explains,
Those emissions by 2030 could be for a water company 60% of their whole emissions as their electricity grid is decarbonizing.
What are our options here? Well, to start with, we could be extreme.
Just cover all the wastewater tanks in a country and just capture those NOxes and do something with them. But then this would cost billions and billions. Imagine if you did it for the entire country. It wouldn't be the most cost-effective thing for the consumer.
I wouldn't do that if I were you.
Much more realistically, we shall strive to better capture the methane and leverage more anaerobic processes to limit NOx emissions. Or again, nothing against activated sludge. Think of new alternative technologies. Did I already mention that wastewater is actually liquid energy? One thing's for sure, wastewater looks like a low-hanging fruit. Yet, as Susan Moiser recalls, there's a bigger picture.
I would not disagree that wastewater is the place to start, but I think if we only focus on wastewater, we're missing something. If we pull back and we look at this, how we're operating our whole systems, then we'll put the investment where it needs to go.
And where would this investment need to go? Well, renewable power is an option.
This is interesting.
Indeed, water and wastewater facilities often feature large footprints that may be well suited to installing some solar power. The same applies to small network hydraulic production tools. We'll have to get creative. Now, there's probably even more potential in biogas and hydrogen. Biogas produced in a sludge digester is by definition carbon neutral. That makes it a good prospect in the race to net zero. But now imagine taking that biogas and turning it even greener. That's the promise of turquoise hydrogen. I'm only scratching the surface here, but I hope you realize there's a whole picture to address. So by now, we see where we could be acting. But we still need to do that in a purposeful and methodic way. That's where frameworks, standards and toolboxes kick in.
Bingo.
The Asian Development Bank has for instance developed a screening tool for the energy evaluation of projects. It combines a support document that recaps all the advice they collected in pilot and field projects with an XML calculation sheet. You can download it for free, I've linked to it, and of course widely use it. We could also be rethinking procurement. This is a clear outcome of Water UK's roadmap development steps. If we want to move beyond just intentions to change our approach to projects, we need to walk the talk. And that involves integrating the net zero water criterion into procurement procedures. The water industry supply chain can well align to deliver on the promise, but it needs the right nudges from the ones at the top of the food chain.
They say, oh, I want low carbon, but they never ask for low carbon in the contract. So how do you expect your designers, your contractor, to deliver low carbon for you?
I know that's not fair, and I'm very sorry.
Now, procurement won't move without a strong signal from its leadership, and that's where management kicks in.
I see that this comes down to leadership. I see that wherever we're working across the world, that there are leaders stepping up.
I connected those dots and I came to the very same conclusion.
The water industry is a complex beast from its end user to its bolts and nuts suppliers through all the layers of OEMs, EPCs, engineering companies and consultants. But it takes a village to raise a child. And if we want to hit the net zero mark, we'll have to team up. This is yet another reason why events like this year's Global Water Summit are crucial. So where is that village? The obvious answer is in the UK, which is the fast mover when it comes to setting ambitious carbon goals in the water sector. But this very special water scene is not alone on that road. Global Water Intelligence keeps track of the utilities with net zero targets. Beyond the UK, they are to be found in Denmark, Australia, Canada, Chile, France, Germany, and many other places. Today, they serve a total population of 230 million people. In a typical bell curve, those are our first 3%. It's not much, but it's something. So let's take our pilgrim sticks and go out to convince the early and late majorities to join the race by 2025. It all starts with a pledge.
The end.
Are you joining the race? Then make sure to like this video to spread the word. And come tell me how you do so in the comments. And here's the video I was hinting at twice today. You'll probably want to explore how wastewater is the equivalent to 320 nuclear power reactors. Don't you? Thanks for watching, and I'll see you next time.